Hear me out. We can still do the original thing, which I'll have to go look up if you want to.
No. I'm happy with whatever.
Because this is what we did. So, do you know what Devin.ai is?
Only because I've seen like parts of your stream where you've been using it. That's all. I know very little.
Okay. So Devin.ai is obviously this like fully autonomous agent that you give it English requests and it goes and edits the code base and then makes PRs. So we automated that process. We automated the automated by making it so because it turns out Devin cannot push to master. If you tell it to push to master, it's just like, it just can't.
Okay,
It'll just say it's pushing and then just stop working altogether.
Okay.
So
Okay.
we made it so that when it pushes, if the actor in the GitHub CI is Devin, it just automatically merged it right into master. So we just kind of pushed to master by cheating. And then what I did is that I allowed Twitch chat every effectively 3 minutes to send it a message.
Okay.
And Twitch chat built a game.
Got it. Using by sort of indirectly influencing Devin AI's behavior to get to this game.
To get to this game. And so this was I believe it's 126 commits or 126 pull requests merged in to this game over the course of approximately 8 hours of a command every 3 minutes.
Okay.
So a pretty good amount of effort and work went into this amazing game. I didn't actually do any specific checks here. Hold on one second. Let me just go like this really quickly. Find everything with the word JS in it. 1,300 lines in 8 hours was created.
Okay, not bad. Not bad by Devin there.
Yeah, not bad. Also, there was some HTML. Another 200 lines of HTML. So, like a lot of things happen. So that means some CSS, some inline JavaScript, and then all the other stuff that goes with it. So, like, a good amount of work went into this.
Now, just so that I have some awareness of Devin AI in general, because, of course, I don't really know much about it. Did you specifically ask Devin to do this in JavaScript and HTML, or did Devin choose that? Did you just say game and his go-to was JavaScript?
So, great question. We chose it this way because if I didn't, I would somehow probably get my my system deleted. I'm not that good of creating containers. So instead, this allows us to have GitHub user pages. So I can do this whole the Primogen GitHub game. Hold on, this is the other one. This is the one they created yesterday for me.
Okay. Oh, I love that blink. I love that pulsing tab. That was that.
There's so many. Dude, that one was so cursed. And so this is what they created right here. Is this beautiful game?
Right.
And if I hold on, automation is playing.
What the heck?
Hold on. So it's a Doom-like game. I can shoot.
I see.
And you can see that the bullets are very weird. And after sorry, my controls are in Dvorak, but that's WASD. That's a anime girl, and I can shoot it dead.
Is it?
And look at that. You got the mini map. Look at how it kind of goes through the wall a little bit until it exceeds a certain amount, and then it disappears.
Oh wow! And it kind of has a health bar there.
Yeah, and it's slowly coming towards me. And as I move, you can even see in the mini map up in the corner where chat is. You can actually see where all the bad guys are. So there's a bad guy right here-ish. So if I strafe, you can see it comes into view. Then I should have two over here based on the mini map.
So did it add the like weird crap falling down on the side of the screen too? Like, what is that?
So again, Twitch.
If you don't mind me asking.
Twitch chat had 8 hours to make whatever they want, and they decided to make fire and cheese.
Okay. So this was a request to the AI. Please make fire and cheese rain down on the side.
Yeah. And so now this is the automated player. They also added an automated player that just moves randomly and shoots at. And if you run into enough of these ghosts or these hot anime waifus, if you run into enough, enough of them, you'll actually die and you'll have to reset the game. So soon.
Very, very NSFW there. You're gonna have to put a content warning on this bad boy.
All right. So what I think would be fun is who you've probably seen a few games in your day. You've probably read through some code in your day.
Okay.
What if you decided that you would like to look over the code generated, and we can see How does this match up? What is the game loop like? What did Devin produce? How's the math
Okay.
looking? How's the physics organized? Are we looking pretty good, or is it complete rubbish?
Okay, sure. I mean, let's, I guess we're code reviewing Devin here. First, I guess I would like to say to Devin, good job getting something running. I mean, you know, AI is an emerging field, and it's kind of always a little touch and go. So, you know, it kind of produced something like what you probably asked for. No one would want to play this, but it's at least it looks sort of like what you asked for.
Yeah, this
Probably.
is Doom
I don't
with
know.
anime waifus. That's like was the premise of the game that Twitch decided to make.
Well, I don't know if it's Doom with anime waifus. that might be a stretch, but it is some blob walls with a ghost creature, and that's something.
No, it is Doom, and that's anime waifu.
Okay, I'm sorry. I'm very sorry. Yes. All right. I'm not familiar with that much anime, so I'm sure it's just my unfamiliarity with the genre that's causing me to misinterpret this hot waifu as a ghost creature.
Yeah, you're just uncultured, is what you're trying to say. You're
Yes, that's right.
uncultured swine. So
I'm very sorry. I apologize.
yeah, I apologize to all the weebs. Not that they're actually gonna hear about this or be upset enough to do anything about it, but they're, you know.
Yes.
So,
Okay.
all right. So now that you kind of have the idea of it, also, chat decided to name it Chussie. Chussie 2, by the way. It's not. They actually made Chussie yesterday and Chussie 2
Okay. All right.
for the remainder of today.
I like that a lot.
Okay, it's a good name. It's a good name.
Chat 1, Devin 0 so far. It's my first comment. Chussie 2.
All right, so obviously
right.
there's a lot of JavaScript going on here. There's like some initialization of the canvas, some target frame rate stuff, a big state object. So I mean that seems like you kind of recommended me on a simple game to make a big state object and just kind of throw everything on there for ease of use.
Can I ask a question already?
Yeah.
So how did it choose to implement that target FPS in JavaScript?
Well, I think because at one point it was 30, and then chat said that the frame rate sucks, and so it just said doubled for smoother gameplay.
No, but I mean, how did they implement target FPS? Like, I'm assuming they use like the callback, the render callback in Java. Like, how did it implement it? How did it
so
implement
you're about to
update?
see.
That's what I wanted to know.
You're about to see, my friend. Okay, it's gonna be a thing of beauty. Okay, so let's just go straight into the game loop. Okay, so the game loop.
Okay, so it request animation frame. That's what I was wondering. There it is.
Yep.
Okay.
So we do a request animation frame. So it does a game loop. And apparently, I didn't even realize this, but request animation frame, every single time it's called back, it actually has a callback. I actually didn't even know this, that there's a callback that apparently does, that provides in the current timestamp at the moment.
Yes.
I didn't even know that, so that's pretty cool.
Yes, I have written this exact code before. I mean, not this exact code, but because this is a little weird. But the request animation frame with the timestamp. Yeah, that's why I was wondering what it did. But that's correct. That's what you would do if you wanted to make a game in JavaScript. So off to a good start, Devin.
Off to a good start. I'm not exactly sure the precise timings of a request animation frame. I assumed it's tied to your frame rate of some sort, or is it? I assume it's not just deadlocked to 60.
So request animation frame I don't think has any guarantees. It's just a thing that says, as soon as possible, browser, please call me back and let me render. So if you want to keep animating, when you prepare your frame, if your goal is to continue to provide updates, you call request animation frame when you're done. If you're paused or like not doing anything and you're just going to wait for some user input, then you don't call it. That's basically how it works. And then you use the timestamp to figure out how long it was, because you don't really get to say.
Yeah, but yeah, my general, I thought, I was confused. I couldn't remember if a request animation frame simply calls when there's nothing left in the process event list, or if it actually waits for like some 16 millisecond or some appropriate amount of time to be called back to do the next animation. But either way, it doesn't really matter. They a nice little game loop right here, right? It calls game loop. If we haven't waited enough time, then we request animate. We just keep on waiting some async amount of time. And then the moment we do actually pass it, we're like, all right, here we are. We are this. Does some canvas clearing. And then the first thing it does is it draws walls.
Okay. Well, I mean, probably. So the problem here is Devin probably doesn't know how to do like a depth sort here, which is since the canvases don't support Z buffers. So, it's got this problem of it's got these ghost enemies, right? And it needs to insert them into the draw order somewhere. And Devin probably doesn't know how to sort like a Doom world. Do you know what I'm saying?
Yeah, I think I'm seeing what you're attempting to say. But yes, it starts by just rendering all the walls.
Yeah, which isn't going to work, obviously. This is why it has to do that the ghost disappears thing, I assume.
Yeah, and then it renders all the enemies.
Yeah, I mean, then that's why they're going to have to disappear.
Yeah,
right? Because it can't partially render the enemy. It could try to clip it to the walls, but it's probably not smart enough to do that. I guess we'll see. I mean, it didn't look like it was doing it, so we'll see.
Yeah, and then after that, if the player has died, it then brings up the pop-up that said, "Hey, you've died."
Got it.
And so then now we start with the updates. Which is that a normal thing to do, to render stuff out and then to do some sort of physics style updating?
No, it's backwards, and for the obvious reason that it means everything will be delayed one more frame than it should be. So usually the way you look at it is you want to process the input, do the update, and then render to reduce the total amount of time between when the input comes in and when the render occurs. So typically what you're trying to do is process updates before you render. And if you process them after you render, you have to wait one more whole time of input processing, right?
Yeah.
So it doesn't really matter. The order is not so important as what occurs next to each other, right? In other words, like, I mean, you could argue about what should come in exactly what order, but like, you really don't want to do probably what this is doing because the input now is going to have an extra frame of lag, probably, right?
Okay, that makes sense. And then it does a little checking for collision. If there's a collision, it does some basic, it does some sort of context, right? It does something there. I'm not quite sure exactly what it's doing there. I don't know what it's drawing.
Let me take a look.
It looks like it's doing, that looks like yellow. It's drawing something one more time.
Arc screen. It looks like it's trying to do an overlay, right? Because global alpha is 0.5, so it's going to do like a sort of applying just some pale yellow.
Yeah, right? It looks like it's doing it. It's drawing the bullet one last time and then calling false. Because remember, this is a filter function. So we're actually going to take the array of projectiles, copy it, and only have the array of the projectiles left that are still alive.
Okay. Wow, that is a weird way to do it. All right. Okay.
Yeah. We're here though, so it draws it one last time. You know, one more time for the old times. You know what I mean? You know, for the old times.
And I guess it's the alpha is 0.5 because the bullets are transparent or semi-transparent. Is that?
I assume that it's since it's dying. Maybe it's like halfway there for one frame.
Oh, okay, got it. Yep. Nope.
That makes sense. And then it goes and checks collisions for the enemies, and kind of goes through this whole like enemy list and goes through every one of them. Sees if it actually hits any of them. It just does its distance based on 0.5. It doesn't really do anything other than like if it's close enough, you get hit.
I mean, since the things are roughly spherical, that seems good, right? I mean, maybe that's the wrong number, but like a sphere will hit something when it's within that distance, right?
Yeah.
Roughly speaking, because it's the same in all dimensions, so it should. Seems okay. I don't know how big the spheres are supposed to be. I guess I didn't really pay close attention to that.
I didn't pay close attention either. I just assumed that was correct because it does this whole thing, right? It gets dy dx and then.
Yeah, let me see. Yeah, that looks right.
Yeah.
Yeah, that looks fine because that's just doing basic Pythagorean theorem, right? Like,
yep. So yeah, when the distance betwixt the two is within it. So quick question, do they normally do distance or distance squared? Because you kind of avoid, do you like want to actually avoid the square root, or is that, hey, we are so powerful now that we just don't even care if there's a square root in code anymore?
Yeah, I mean, the way that I would probably phrase it is an actual game developer would probably not write the code this way unless they actually had to for some reason. So you do still want to avoid square root because it is very expensive compared to something like a multiply. So if you look at the breakdown of costs of things here, subtraction, you got two subtractions extremely cheap. You got one, you got an FMAD basically, a multiply and an FMAD extremely cheap.
What's
All
an
of those things
FMAD?
An FMAD is a fused multiply add. It's when you multiply two things together and add by one more thing. So like if you looked at that thing, it says dx times dx plus dy times dy. In that, you wouldn't have to do two multiplies and an add. You could just do one multiply and one fused multiply add. Does that make sense?
Yes, I think so. Yes. Because the fuse multiply add just simply takes the result of dy times dy and adds it to dx. Right? It does those two operations in a single order. Okay.
Exactly. And
or by single, I mean there's many micro. It's a single micro op. Is that what the term is? And then there's actually many CPU ops underneath the hood. Did I get that correct?
No. Micro op is the CPU op under the hood. So micro op's the smallest thing, and those are all single micro op things, like an fmad, an add, and a subtract in floating point. Those are all single ops. So yeah, like if you were writing this code, you probably wouldn't put the square root in there. Of course, that said, like obviously we know we're not thinking about performance right now. I mean, this is not even vectorized, so we're doing this like individually. So I try to encourage people not to like overthink optimizations in a setting where they've clearly not been optimizing, right? So a square root isn't horrible, right? A square root is, I mean, I don't remember what it would probably be, like maybe something like 16 cycles of latency or something like that. So it's not good, but it's not like hundreds of cycles of latency, right? It's not like it used to be where it was like, oh my God, do not touch a square root. So we are much better at those than we used to be. So, it's fine. But anyway, so
awesome.
Yes, as you pointed out, though, normally you wouldn't do the square root because in this case, you're just going to check a distance. And so what you would normally do is square the distance and then check against the squared distance because that avoids the square root altogether for free. So typically you would just square that 0.5, right? So you'd say 0.25 and check against the squared distance. That's what you would do. That's what a game developer would normally do because why, do it. So anyway, yeah.
Okay.
But yes.
Awesome. Okay. I like where this is going. Okay, then it does a little bit of damage to the enemy based on the projectile damage.
Yes.
And then it does another drawing, some sort of half drawing of what it appears to be the bullet's half drawing. And then it also checks to see if the enemy's health is below 0 and will also remove out the enemy at this point.
Oh, I like this as drop ammo when enemy.
But
did it drop any ammo?
It doesn't actually drop ammo. What it does is that it takes
it
ammo and it creates 3 to 7 bullets. You can't really see it based on your screen. Here, I'll move it back out a little bit. It creates 3 to 7. Here, let me make you just a touch.
Yeah, can you shrink me down a little?
Here. I'm going to put you down here, and I'll put myself up here because I don't take as much.
Right, yes.
I have that whole like transparency thing going on, so I can kind of avoid a lot of it.
Yes.
So it actually creates an amount of 3 to 7 random bullets, and then just adds it to your bullets. So it doesn't actually drop anything; it just gives you bullets every time you kill an enemy.
It's a drop with auto collect.
Drop with auto collect, regardless of the distance, which is also kind of funny because we asked it to drop ammo when the enemy dies, and this is how it interpreted dropping ammo when enemy dies.
Yeah, again. I'm just thinking of Devin as like kind of the summer intern that you didn't really want, and so he's trying. You asked him to put in an ammo drop, and this is what he did. It's kind of hey Devin, nice try anyway.
What do you think about removing? How do you feel about like just this overall thing of going through the enemies, finding ones that it hits, removing the bullet, but also removing the enemy if the enemy is dead in this round based on when the bullet collision happens?
I mean, again, it's like pat the AI on the head and be like, well, you tried. The reason that we don't do any of those things, right? If you were to look at actual game code, there's a couple reasons, and I'll give you an illustration. So the number one reason that you don't do that typically, just baseline, is you typically have to do some kind of an animation. So when the enemy dies, typically, in a modern game, it can't just disappear. That's like thinking of 1978, thinking Pong or something. Right? Yeah, or asteroids maybe, right? So really, really primitive, barely any hardware. Maybe that's a thing you might do. In a modern era, you typically need to show like the thing that you hit taking some damage or falling over, or it's got some state you need to preserve, like what was it carrying for armor and all, So typically you're not going to just boom, delete the thing, because you'll lose all the state information that you actually need to provide the correct death animation or anything else. So that's kind of reason number one. But reason number two, which is also very important for any kind of non-trivial game, is that typically your enemies have, any entity in the world is going to have indirect references to it at some point, like someone's targeting that enemy or someone's chasing that enemy, or there's the state that wants to be able to talk about a particular enemy. And so your only two options there.
Sorry, I'm laughing about something. Can I just read this to you really quickly? I'm sorry. It tickled me.
No,
It said,
go ahead.
to be frank, with the amount of abuse hurled at Devin, any experienced dev would be reduced to a summer intern quality. Twitch was not very nice to it.
Oh, Twitch, come on now.
Sorry, it tickled me while you were explaining. Please, go on if you can remember where you're at.
Poor AIs. Okay. If you don't like the people who make AI, that's totally fair. I can understand that. But the poor AI, I mean, it's just it's like this weird little orphaned child. I mean, it's just its life is horrible. So yeah, I mean, and it's not even getting paid, right?
Yeah.
So anyway, but yes, so the other problem is that typically you need to be able to refer to entities. And so the way that we typically do that to avoid having yet another table that you look up into or something like that is you just don't you leave that sort of entity array, you leave it as sort of a sparse array. When something is going to be killed, you just mark it as dying, but you don't immediately remove it. That way anyone who was looking at that thing, who had like an indirect reference to that thing, isn't suddenly holding the wrong index or a null pointer or something, right? Because imagine what's going to happen in this state. Some other entities like trying to chase this person who's going to get shot here, and it's holding index 3 because that's like which enemy that was. This guy dies, it gets removed from the array. Now that person who's looking at index 3 on the next frame goes, oh yeah, there's still an enemy there, but it's the wrong enemy now.
Yeah.
So there's now this hidden bug in the code that's kind of hard to see, and you'll see these manifestations of these bugs where people are like targeting the wrong thing, and you're like, well, how did that happen? It's like, oh, it's because he locked onto that enemy and was chasing him, and then that enemy died, and so then all of a sudden the entity that's in that slot is halfway across the world, and so he starts walking that way, right, or whatever, So you'll see stuff like that happens. So we try to eliminate those sorts of things because, like I said, the only alternative here is to have another lookup table and then use handles, which you could do, or you have this splice is like a broadcast, and everyone, when I delete it, everyone who has the handle has to update it, right? You don't want to do those things.
Yeah.
So typically you do something like an index or a tagged index is often what we'll do. We'll make the index. You'll use a thing that's the index plus like a unique identifier. And when you go to like target somebody using that, you'll compare the unique identifier versus their current unique identifier, and if it doesn't match, you know that the actual one died. Does that make sense?
Oh, nice. Yeah, that way you can
what I'm
maintain a tight table still. It doesn't have to be, because, obviously like a sparse bullet table within like a minute would be, hundreds of thousands of entries. It'd just be gigantic.
Yes.
So that makes sense because that's effectively how hash tables work, right? Is that it doesn't just store the key you looked up, it also, or in the object column, the value column, it actually hiddenly stores the key that was also used to generate it. So that way you have this nice little kind of round reference there.
Exactly. So a very common technique might be to just use a 64-bit integer to refer to entities, and every time you create an entity, it gets a new 64-bit integer, so it'll never wrap in the history of game. You've ran this game till the heat death of the universe. And then what you'll do is you'll store that 64-bit integer in the entity struct, and everyone who wants to refer to it will use it. And it'll just be like the bottom few bits, like the bottom 16 bits or something, will be the part that actually says what its index is in the table. And the other 48 bits are just that unique key. And that way, every time someone goes to look at an entity, they just compare it. They go, oh, it doesn't match anymore. That, bro must have died. So I'll take whatever action I take when I see the guy die who I was following or whatever.
Okay, nice.
That's, you know what I'm saying? Yeah.
Yeah, that actually makes a lot of sense. Then we check to see if the bullet is too old, and then we die if it's too old.
Okay. All right, limited lifetime bullet. Got it.
Yep. And then after that, we just draw it if it's in our view.
Screen extra and canvas width. Okay.
So screen exit does this world to
why.
screen. It does this whole world to screen thing where there's some sort of projection going on here. I obviously don't quite understand what this is, but it does some sort of player angle. We looked up what this does. This normalizes the distance between two angles to be on negative pi to pi in the correct direction, the most efficient turn to get there.
Yep.
A little arctan too.
Give me 1 second. I'm sorry to be boring. I'm just going to read through this, see what it did. Okay. If a V project on the screen. Okay. All right. Yeah, I mean, this is pretty interesting. I guess the most interesting part of this to me is, I guess, I'm not sure. This is very atypical for how you would project something onto the screen, I guess is how I would say it. And so I'm wondering why, because my understanding of these AIs is like they're trained on code, right? So it had to have read this code and presumably read this code a lot. Like, it had to think that this was like the way people did this. I'm kind of surprised because normally when we project, it's just it's much simpler than this. There is a little bit of the FOV usually gets baked down to a constant, so you wouldn't normally see it in the middle of the world to screen projection. And so yeah, I wish you could ask the AI, like, what code were you reading where this was how they did it? Because no one would do it this way. This is very expensive. And ATAN2 in the middle of the projection function is just insane, right? ATAN2 is one of the most expensive things you could be doing. You would never, right?
Okay, well, I didn't know that, but thank you for letting me know, because I always just thought ATAN2 is the ultimate math function to just figure out everything with my vectors.
Yeah. Well, if you absolutely positively need to take an angle of something, then, okay, maybe you called ATAN2, but you have to remember ATAN2 doesn't exist in the CPU, right? Hasn't existed since well, technically there's still a legacy path for running it in x87, but you can't really do that and expect it to work in a modern context. So assuming you're running a modern x64, normal architecture, there's no ATAN2. So ATAN2 could be this big function with a bunch of polynomial approximations and branches to try and get you the bits that you asked for. In this case, correct me if I'm wrong, because you're the JavaScript expert, not me, it's all going to be in double precision arithmetic.
Numbers are typically, it's not quite double, but it's like 2 to the 53 minus 1 is the maximum integer you can represent, and I think there's some level
That's double. That's double.
That's a double. Okay, I know there's some oddities to the JavaScript number. I think it largely adheres to the 754, but I'm not exactly sure if it is fully that or how it plays around with the exact double representation. I don't know. Because I think there's a tagging that goes on.
It's possible that the ATAN2 is specified at less precision or something, but normally a double ATAN2, very expensive. You're talking about tons of those FMATs we talked about before, branches, checking bits, range reduction, all this stuff. So ATAN2 is like a big drop, like way worse than like the square root you were worried about before. Way, way worse than that.
Okay.
Square root exists in the processor, right? Square root's an actual op. ATAN2, no such thing.
Just a fun side quest. Why did ATAN2 used to exist and now it doesn't?
Any question that starts with why about CPU architecture is always a little dicey to answer, so please take my answer with a pretty big grain of salt. But when they created the x87, you have to remember that this is back in the old days of computing, and x86 was the main chip, and x87 was a math coprocessor. It was like a GPU, right? Like you put it in as an additional chip, right? Does that make sense?
Yeah.
Originally. And so it's for, scientific computing and doing math and stuff.
Yeah.
So for at least the first, N years of the x86, x87, not only was it separate, it got eventually welded in. I think by the time you get to 486, it becomes part of the main die permanently. And then 586 and on, it's always part of the main die. But For those first, 8086, 8286, 8386, I'm pretty sure it's always separate. And so it's doing it's thinking of itself as a math chip. So it's 80-bit precision, more than double precision, more than 64-bit.
Yeah.
80-bit precision, right?
It's a lot of precision.
A lot of precision, and it has everything. It's got sine and cosine, it's got A10, it's got square root, it's got everything, right? And they're all implemented as basically the chip itself sitting around doing iterations of various algorithms like, Cordic or Newton-Raphson's or whatever they're going to do. The chip itself, because it's faster at that time than actually processing instructions, the chip itself is going to do tons and tons of work. 50 cycles, 70 cycles, 80 cycles worth of sitting there doing work to produce the bits very slowly, right? When they go to x64, they're like, we're not doing this anymore, right? It's way faster if we just provide the fast, fundamental ops like plus and times and things like that. And then you just write in your code the little routine that does as much of the A10 precision as you want. It's not going to really be any faster if we microcode this, right? Like we're not really going to get much out of it. So I think typically what happened was at that point they're just like, we're only going to accelerate things we're actually going to accelerate without a significant amount of microcode. So they do put in things like table-driven divide, table-driven square roots, where the chip is actually going to do it faster than you're going to do it. But they didn't bother doing all of these other things like ATAN2. There's like, we're not going to accelerate ATAN2. It's just not important enough. And the amount of chip real estate we'd spend on it, it's not it, right?
Okay,
so
and that's because a lot of that
you
could develop your own 32-bit version of ATAN2 that is a series of multiplies and whatever. And since we have fancy compilers these days, you're effectively getting the same amount of microcodes that they would be able to do it in. Is that like the basic argument? And then you get to choose the precision, which allows you to actually have like a much faster version?
Well, it's not just that. I mean, I think what you're saying is true, but also it's just like I think they didn't want to add instructions to the architecture that they weren't actually going to accelerate. Okay. They could, right? They could go, we're going to make a really fast ATAN2, and they can put in lookup tables and because there's these specific algorithms that work, especially with things like an ATAN2, or like sine and cosine, periodic functions like that. They have these algorithms like the Cordic algorithm or things like that that are specifically made for doing little like add shift, like repeated adds and shifts that hardware can do very well, that can rapidly converge on the precision that you need by adding one bit every time you do those. And you can do several of those a cycle sometimes and so on and so forth. And they have these little lookup tables they can put in there. There's all this sort of stuff, right? And so if they were like, look, we analyzed all this code, and ATAN2 is like a big deal for all of our customers, they absolutely could accelerate ATAN2, right? But what happens is they look and they go, there aren't all these games out there who are like bottlenecked on ATAN2, whereas if we gave them a fast ATAN2, everyone goes from 30 frames a second to 120 frames a second, so get that ATAN2 in there, it's worth the chip real estate. They look and they go, ATAN2, we can avoid it most of the time, sometimes it is there, and yeah, okay, so it takes 100 cycles to do it or something because we've got all these FMAD, whatever, right? It just doesn't end up being something that's going to be worth the chip real estate. So that's why they don't put it in. They could. It's just not worth it.
Okay.
That's what I would say.
Okay. Hey, that was great. All right. So we're going to go on. It does a little bit of drawing of a smoke tracer, which I've yet to see.
Yeah, where was that?
I don't know. We have yet to see it. Okay. It draws a yellow bullet, draw a smoke tracer. Not really sure what this comment means with this right here. So it looks like it does it again. Yeah. It kind of looks like the same thing twice, almost to the T.
Yeah, it doesn't look like there's any smokiness about the first part of it.
Yeah, this is just very smoky. And then it draws the yellow bullet.
Okay.
Yeah, the arc obviously being 2 pi, so that's the circle, does the whole little thing.
I mean, is what we're seeing, and I'm just asking you because now you know a lot more about this AI stuff than I do, because you actually had the little tiny grad and everything going, so you've had a little look at the insides even, right?
Just a very small peek behind the veil.
So here's what kind of confuses me about this. So once again, like looking at this code, like this is awful, right? Is one thing I would say. You look at how I mean, you know, I'm a person who doesn't abstract unnecessarily, right? I'm always telling people unnecessary abstraction is very bad. Don't abstract things. You just write the code to do what it needs to do, and you're done. So, you know, if it's coming from me, that you're getting the least, you know, you could find people who would tell you to abstract out 10x more times than me. So I'm like way at the bottom of that level, right? But I'm just looking at this and just think about what would happen if we changed a little bit about how the projection was working. Like, look at all this stuff that they're doing here, like with the screenx minus math.cosine project.angle times width. Like, you would never want that expression to be repeated this many times. It makes it impossible for me to change how I'm doing the display. All of this stuff should be in some kind of standard projection model that we're just using, right? And so, again, I'm wondering, what was this trained on? Like, this must have been trained on real garbage code. I mean, I guess just get whatever's on GitHub, right, or whatever. It's just not good.
Well, first off, yes, it was trained on garbage code because, I mean, we've all been guilty of writing garbage code. And we actively attempt not to write garbage code. And so I am never surprised when I come across garbage code on the internet. And so it's even worse under people's personal projects when you don't care, right?
Yeah, I think we're seeing that now. It's like, right, you know, what do I put on GitHub? Like, I don't put any of my real stuff on GitHub, right? It's all this like one-off there, like, oh, someone wanted that, all right. Here's this garbage thing on GitHub, right? And so, yeah, I mean, that's what this looks like. It looks like it was getting trained on someone who has typed something in and they really just did not care about it at all, or maybe they were a novice. That's also, I don't want to unfairly diss anyone who's written code like this. When you're starting out, you're going to write code like this, so that's fine too. But that's not what I want to train my AI with, right? I don't want to go back to when I was first learning to program and train my AI with that, right? I want to train my AI with what I'm writing now, you know?
And that's obviously the hard part of an information-hungry algorithm, which is the whole training, which is the whole pre-train process, which is that you just need millions upon millions of lines, and so you don't really get to be very selective. You're not grabbing from the Carmacks of the world; you're grabbing from everybody.
Yeah, the Carmack is the 0.001% of the source code, and the other 99.999 is this, I guess. So yeah, you know, it's kind of crazy all this stuff it's doing like that, and I just wanted to mention that part because in addition to doing this, like a lot of this stuff is not necessary. You're repeatedly taking sines and cosines of angles for no reason, and all these other sorts of things. In addition to that, you just also have this fact that this is very brittle. If you wanted to now modify this to do a different method of projecting things onto the screen or a different idea of what the world space was or anything like that, this is just very fragile, and it forces you to go edit all of this stuff. Like, you know, you're editing it multiple times just in this one quote-unquote
just on a
smoke
bullet
tracer.
Just on this one bullet, there's 5 different rendering paths.
And they all have to line up or it'll look weird, right? Things will show up in different places, right? So, you know. But anyway, keep going.
All right, so by the way, I did want to say one thing that's probably unique that I think really goes to show the difficulty of the maintainability of AI is that, remember, this was over the course of 126 commits to a GitHub project and over the course of 8 hours.
Yes.
Devin or any AI doesn't really have the good citizen. And the good citizen, of course, is somebody who, when you come across a piece of code and you see how, oh, okay, this place over here that's, you know, unrelated, I know I can kind of make these two things really nice. And I bet you some point in the future we're going to want potatoes on the screen. So therefore, I should probably, you know, I know it's coming. I should probably think of a way to reconcile this right now. There's no good citizen. It's just it's just politicians. That's it.
No, I know exactly what you mean. Sometimes I've called that. I never heard good citizen. That's a good one. I just call it the static discipline. There's this thing in in electrical engineering where they're like, whenever a signal comes in, and you're designing something, you want the signal that comes out to be at least as clean or cleaner than the signal that came in, right? And it's like that's, you know, when you're looking at code, that's what you want to do. If I'm going to open up something, I'm going to change it. I don't want to just do the minimum work necessary to change it, right? I want to go like, okay, can I improve this at all based on my change? Can I leave it better than I found it, right? And I think that's what you're calling good citizen, yes?
Yep. Like, we call it a good citizen, which is a two-way sword, by the way. Because the two-way sword, of course, is that you look at the wrong piece of code and you go, okay, this is what good citizens do. And so good citizens also make pathways to hell pretty quick as well, which is that you end up propelling the wrong idea in the code base.
I see. Okay. Fair enough.
All right. Anyways,
Good citizens gone bad.
Good citizens gone wild. So anyway, so at the very bottom, if we finally got to the bottom, we return true, and that will not filter out this bullet. And so every single frame obviously copies the bullet list, all active bullets. But I mean, largely bullets are short-lived. There's not going to be very many of them. You could argue this is fine, whatever. But nonetheless, there it is. Then we draw arms. You may have missed the arms.
I did miss the arms. Can you
So
show
if
me
you
the
see
arms?
right here, this is one of the arms.
Okay.
Here, let me make you a little bit shorter. Here,
What?
there's
What
another
is
arm on
that?
the other side. Okay, so watch this. I want to restart this really quickly. If I
Did they
press
move?
up, I froze. Hold on, I'm just gonna do this. If I do W, they move up and down.
Oh my god.
D, yeah,
Yes.
I know it's pretty great, huh?
Oh
what is
my
it?
god. I hope Devin got hired for that.
It's
That
actually
is
it's a pretty amazing little like side feature if you didn't notice it.
Wow. Great work, Devin.
Oh, I just realized I found a bug. Hold on.
A bug in this code? No.
Yeah, I know. All right, there we go. So we got that thing down here. We'll leave it. Okay, so we draw the arms. We draw the HUD.
Okay.
Now, we're getting into the part that I thought was really, really, really interesting coming up here. Then we do this whole...
Prime, I don't know if you're in a rush here, but you're kind of skipping the money shot there. I want to see that draw arms.
Oh, the draw arms.
You got to at least show me the draw. He's got a little bob. Like, it's moving up and down and stuff. Like, that was...
So this is something I don't quite understand.
Sign of swing offset. Look at him go. Look at Devin go.
This is something
Yes.
I don't understand, which is this right here. The number of rays
Okay.
is the width of the canvas. So we're going to do all the pixels of the canvas.
Whoa.
We're going to go over all of them. And if I equals the canvas
okay.
width between these two locations,
Yep.
which is either going to be, or it's, wait a second. Actually, I didn't even read this. Okay, actually, they do this in another location, but this is actually way more funny.
I see what they're doing. Yeah.
They do one check on point 3 and one check on point 7, and then I didn't even look at that. That's so good. Oh
That's
my god!
amazing.
They loop the entire
amazing.
canvas just to draw it on two constants.
You laugh, Prime, but Devin here is just using a implicit function for arm rendering, right? The sign distance field people in the audience are cheering right now, right? Because they know that the way you render something is you loop over all pixels and you ask, is it this pixel? And that is what Devin has done here. He's going implicit on you.
Yeah.
Now, granted, in this case, that's a really bad idea, but, he gets the concept. He knows what it is. I love it. I love it so much. And the math sign player arm swing offset is even better. This is great. This is
20.
this is the best code. This is the best code in the game. That's it. We can look at the rest, but just I want it to be known that I think that's the best code.
Okay, well, wait to be impressed. We still got a lot left. And I told you that I didn't look at that code very strong, other than I laughed that it's drawing arms. I wish I would have looked at it, seeing that it's actually just two. It's literally just two constants.
So it
because
must-
you could just use that one, right? Like that's position 1. Like that's a known it's a known value.
Yes. So it must think. I mean, in its whatever the AI has for a brain, right? In its giant parameter matrix, right? It must be like, well, they told me to do Array Marcher, right?
Yeah.
And the way you render stuff in Array Marcher is I gotta go and look at all of the columns and see like which ones should be which size. So I gotta draw the arms. That's what I'm gonna do, right? So.
Yep.
I kind of like it. I mean, it's very AI, right? It's very AI. You can see why it probably did that.
Yeah, and I guess to be fair, multiplying the canvas by 0.3. No, that should only yield one number. So this is only drawing one pixel, right? I'm not. This is one pixel. Effectively, this is one eye, and then this is one eye, right? There's no way this is capturing some group of eye.
Correct. It's not capturing a group. It's just, well, I mean, that's based on my limited understanding of I'm assuming that the way that the canvas works is that one integer number is 1 pixel in the canvas. Right? I mean, I assume that's what happens.
I assume the width is pixels.
Scale.
I assume the width is pixels. But even if it wasn't pixels,
Yeah.
even if it was foibles, right? A word we don't even understand. This is a constant. This only boils down because it's a math.floor. So this only boils down to a singular number. So this thing would only hit it once on its scan across the whole list.
It only hits it once, but I'm just pointing out that could map to multiple pixels if the canvas width is not. It's not talking about integers. That's the only thing I don't know how that mapping works necessarily. But I assume canvases have a transform, so I'm assuming all of this is kind of predicated on, like, one of the interesting things about this is canvas.width probably isn't actually going to work if you've got a transform selected in there. So I'm assuming that there just isn't a transform selected in there or something.
Yeah. I have no idea.
Yes.
All right, anyways. Okay, we got some good stuff. We got the HUD, the heads-up display. So this does actually what appears to be some pretty basic, hey, here's your health bar, here's your gun icon, here's your crosshair. So I'd actually say this was not the world's worst code going on here.
Okay. Gotcha.
Right.
Max bullets. Bullets over max bullets.
Yeah, classic.
Love it.
Love it. All right, so we're starting to get into the interesting world, which is the keys world. When you see the input is a very special beast, and it gets the most special during the player movement. So now remember, at this point, we've rendered walls, we've rendered enemies, then we updated bullet position and destroyed enemies if we've hit them, and now we're getting into updating the arms. Of course, we update the arms so that that way they're rendered differently next frame.
Yep.
We render the arm at the current state and then move it for the next state. And then we get into player movement. Now, this is where for me, this was my personal favorite function.
Okay.
So I'll try to do my best to kind of do the basic one I can see right away, is that I'm not 100% sure what's going on here, other than we are just calculating the player's angle, multiplying it by our acceleration, and setting this to our velocity. I think we're effectively making it so that we can't exceed a certain amount of speed, right? This is doing some sort of normalization over the XY axis, but I think it doesn't quite normalize. It's not like an eigenvector normalization. I think you can kind of get into a position where it's like too much or too little.
I don't think that. I think all that's doing is just applying acceleration. So all it's doing, so math cosine, so whenever you see cosine sine like that, all that's doing is turning an angle into a vector that points along that angle. So all this is doing is effectively saying player.velocity plus equals player.acceleration. That's it. And the cosine and sine are just to make sure that the acceleration goes in the direction the player is currently pointing.
Yeah.
So this is just, that's all this is, no normalization.
Okay. I couldn't remember if math.cosine and math.sine of the exact same angle, if you add them together, equals 1 or not.
Well, remember, we're adding it to two different things. We're adding it to the x and the y.
Yeah.
So they're not getting added together, which is why. So they will produce, so cosine and sine will produce a normalized vector. But again, we're adding that to an existing vector. So the reason we're multiplying by acceleration is we're just saying this direction, accelerate this much along that axis.
Yeah.
Right? Along that direction. That's all we're doing.
Yeah, that's
so
what I meant
velocity,
by normalization, is that it's gonna create a fixed amount of acceleration that's always 1 in whatever way you're looking.
No, it's going to create an amount of acceleration that is whatever that acceleration number is.
Yeah,
acceleration.
That's what I meant by 1, is it's whatever this number is. It's just ensuring that one acceleration unit is applied correctly according to your direction.
I see, yes. Sorry, I misunderstood you. Yes.
My bad. I'm not very good at explaining these things. I'm not good at this. So then we got our W key, our S key. So we do some adding of the velocity, minusing of the velocity, apply a little bit of friction, you know.
Once again, I'll call it out there for poor Devin. Normally, the way you would do that is first you would just compute the acceleration. So I would just go, if keys.w, I would add player.acceleration to acceleration. If it's S, I would subtract acceleration from player acceleration, and then I would just do that equation once instead of repeating it twice, which again creates duplicated code. You know what I mean?
Yeah.
But keep going.
Then we apply a little bit of friction. Friction being,
frame
of course, classic
frame rate
0.92.
sensitive, so not good. Not great there. Right?
Oh, that's true. There's no delta anywhere in here that actually is.
Yeah.
Oh, you're totally right, because this is only adding it. Even the velocity is also frame rate sensitive.
Yeah.
There's no delta going on here, so you're not even getting like a proportional amount of acceleration based on the amount of time passing.
Yeah, so once again, we would normally, if you're writing this in normal game code, you're going to have some kind of a like tunable parameter there that's going to be the time step. And even if you decide we're going to be like our physics frame rate is locked, so in other words, we're going to just go like the physics frame rate, we're always going to update physics at like 60 frames a second or something, no matter what happens, no matter what our display is or whatever. Even if you do that, you typically use the time step in there because you may decide to make a different decision later. You're like, oh crap, our physics was too slow. We're going to reduce it down to 30 frames a second physics time step. You need to be able to tune that constant. With code like this, you can't tune it at all. So it's just, it is what it is. And now you have to go back and tune all of your different values. So like player acceleration and anything else that happens over time step, they all have to be tuned again. So you typically don't really want to do that. I mean, you can do it this way, but you're buying into that sort of, okay, now we have to remember to tune all the constants for a frame rate separately. But yeah, keep going.
Yeah. Sorry, someone asked, does player dot acceleration change based off delta time? I don't think player acceleration in this case changes off delta time because it is just a constant right here. But typically you'd want something that's, because if for whatever reason something horrible happens on your system and you have a half-second delay between 2 frames, you want to be able to apply a half-second worth of movement, not 1 frame worth of movement. That's why in some games, in the older games, you get that slow movement, right? Or when something like really intense is happening on the screen, you're like, because it's only applying frame-dependent movement.
Yes, and even if you don't care, like I said, even if you're going to use a fixed time step, which is a totally valid way to write a game, you typically just want the code based on a time step anyway so that you can change what that fixed time step's going to be throughout the course of development without having to go retune a bunch of constants like player acceleration.
Yeah.
Right? So it's just what I'm really talking about is just a cleaner way to write the code, right?
Yeah.
It's like, it's cleaner if you acknowledge the time step, even if you then don't decide to make it be variable for other reasons, which there are reasons you wouldn't want a variable time step. So even if you decide not to make it variable, you still kind of want it that way. But it's all right, Devin. You did your best.
Devin's out there.
Doing.
Yeah. Then we check for collisions.
Okay, so check wall collision.
It's probably it's gonna go through every single wall and see if you are within this wall map problem.
Okay, give me 1 second. So we're going through. So the -1 to 1 is like.
I have no idea what it means, to tell you the truth.
Okay. Where shouldn't there be a lookup into some map?
Oh, I see what it's doing. Yes. Okay, I see what it's doing.
What are we
yes,
looking at
right here. So here's the map.
Oh, I can't see that. I can't see that code. Can you scroll that up a bit so it's not under? So I'm not obscuring it. Ah, okay. There we go. Yes.
Yeah. So it's only checking one distance around. It's only checking the squares around your player.
I see. Okay. I get it. Yep. So basically, like, this is not really wall collision. This is more like tile collision.
Yeah.
These aren't walls. These are blocks that are filled in a... Okay. All right. Yeah, so, I mean, again, not fabulous for a number of reasons. Like, if anything, such as a projectile or a player was moving fast enough to go more than one tile in a frame, you would tunnel right through the wall here. So...
Yep.
This isn't really going to cut it, Devin. Sorry.
Also, I do love this right here. Use bitwise or 0 for faster integer conversion. And then we just never use those again. They just...
But it will. You never. That's why he wanted to make them fast. Since they're not used, he didn't want them to take a long time. You see.
Genius, Casey. This is why we invite you on. You just see, have these, you understand programming way better than me, because I would have never saw that.
Clearly, right there. I knew what the AI did. Oh, wow. Okay. All right. That's good.
So we make a check. So if you're not on the wall, then we set your new X and Y. Else, if you are on the wall, we reset your velocity.
Wait, how do you get out of the wall?
Well, that's the thing, is it actually calculates your next position. So, I believe this is one thing physics engines do, right? Is that they actually...
I see.
One step calculates next direction or next
they just
position.
Okay.
Then you check, then you apply.
That's really risky, and I would not ever recommend doing that. And so the reason is, take a look at how this code works. This is just like, you will get stuck in the wall, right?
Yeah.
So here's why. So if you look at how it's doing it, it's doing a standard physics calculation. So that velocity, right, gets updated over time. Like, I'm holding down the key, I move a little bit faster, right? Right?
Yeah,
You can see it's storing the velocity, right? So it's getting
Yeah.
faster every frame. It's getting faster up to the so that multiply by friction there is what's keeping it from going unbounded and just going infinitely fast.
Yeah.
But you're going to accelerate up to that point. If you accelerate to maximum speed, right, tunnel yourself into a wall, now you won't be able to walk out of the wall because on the first frame next time, your velocity won't be as high as it was going into the wall because you've only had one frame of acceleration to get it started. So you won't be able to get far enough out of the wall to pass the wall check. You see what I'm saying? This is a classic, like, everyone's written this code before when they were a kid, right? So this is a classic game developer. I just stuck myself in the wall. So Devin, no, like, do not write this. This is I got stuck in the wall code. You should be able to, if you drove around this thing, you should be able to get stuck in a wall if you want to try.
All right, so now time for my truly favorite piece of code. So after we've done our movement based on the W and the S key, we've applied our friction, and we've checked for collisions. We then apply the A and D strafing keys.
Oh, so there's one frame extra of lag on A and D than there is on S and W.
Yes.
Okay.
And that's because we told Devin later on to change A and D from rotation to strafing.
Okay.
And so it's just like, I know where the input function is. I got you, dog.
And the rotation velocity, so this game has lag on rotation. So when you move the mouse, it like slows down when you stop moving instead of just being instant.
I think so.
Is that what I'm reading there?
I think that's what's happening. I'll have to go look at the input code, but yeah.
Woof. Okay. All right.
That's what I thought too. I was like, great. You never want acceleration velocity.
Oh, you know what? That must be because it was you know what? It probably was thinking keyboard input. That's probably what it was. Because if you're doing keyboard input, then you do need, right? So it's probably thinking keyboard input, and then maybe chat was like, no, make it mouse control or something, and it was like, oh, and then it just changed it to mouse control without thinking about it. I don't know. That's my
but
only
that
guess.
makes that actually does make perfect sense because it was originally. It went first.
There you go.
A and D were turning, and W and S were forward, and then spacebar was shoot. But then we included the mouse, and then okay, wow,
that's exact. And that makes perfect sense with what you described the timeline as. It's also why it happens separate, like second, because they're not thinking this could possibly put you in a wall, because they're like, well, this is some other velocity thing that's going to have to do with rotation, right?
Yeah.
So of course it doesn't go with the collision detection stuff, right? But then it gets changed to velocity, and so now it's just a weird, like, laggy, will get applied next time update, right?
Yeah. It doesn't have. I mean, the thing is Devin's not a gamer. Right?
Okay.
Like, I hate to say this. He's just not a gamer. So, he's never been on Fortnite saying that the real reason why he's losing is that he lost a frame, right? He's going against someone that's on 144 and he's only on 60.
Right.
So he's never had that kind of moment of losing. And so I think he just doesn't even think about, like, the full loss of a frame here is pretty much losing at a game.
He's just like pointing straight up at the sky, trying to figure out how to turn, right? Like, it's just spinning around in a circle. Like, that's Devin.
Yeah.
And he's like, I just came here for the Ariana Grande concert. I don't know what's going on. How do you play this thing? Yeah.
The kids told me Marshmallow would be playing on Fortnite.
There
I
you
better jump in there.
yeah. What's up?
All right, so there we go. So there's the nice player input. Like I said, I truly did find that file to be just a gem. I love the fact that it went backwards like that. It just, I don't know what it is. It just was so beautiful to me. All right, so now that we've gone through, we've drawn the walls, drawn the enemies, updated the bullets, and then deleted enemies or drawn the projectiles or deleted the projectiles based on what happened. Then update the player movement. Will update the enemies.
Right. Okay. And the enemies, by enemies, you mean hot anime waifus. Why are they your enemy in this game? Did anyone explain how that, like, why are you shooting at them? What is going on? Like, chat, I feel like that's chat's fault. I don't think that's Devin's fault.
No,
what is the explanation for that?
It's definitely not Devin's fault. Okay. This is just Doom with anime waifus. It's what they called chussie, because obviously,
all right,
I think the whole joke was cheese pussy is what they're trying to say, because they couldn't say pussy, so they said chussie. I don't know. Right. I have no idea what. I honestly don't know. This is just me acting like Devin, trying to guess the intentions.
You're trying to make a hypothesis somehow out of the evidence we have. Yeah.
All right. So we are now going to update enemies after we check to see if there were any enemies in the array, which we now actually check by seeing if enemies is an array.
Whoa there, dog. What is it doing? It's using the POW function to square the value.
And it sorts
what
it.
The
it
heck,
also,
Devin?
It also sorts the enemy.
Devin. Who's like, I gotta square this thing. I'm gonna whip out POW.
And then squirt it.
Jesus.
So not only do they square it with POW, they also squirt it right afterwards to get the proper distance.
Right, because heaven forbid we sort on squared distance yet again. Okay, all right. So really, Devin is really bringing his A game on that one. It's A game. Is it? I guess I don't want to A game. I'm not gonna. I don't know what Devin is technically, so I'll just say it's A game.
I've been itzing and thang because it's not a. I don't like to anamorphize. Things, and so I'm just like, it's an it, really.
It's an it. Okay.
Yeah.
It's thing. It's really bringing its A game there, but fine. So we've got our sorted list of enemies, which I'm assuming is something that it did because it remembered having seen that you're supposed to sort these things for some reason, and it doesn't really realize that the reason is for to insert them in the draw order. So, oh well.
Oh, that's such a good point, because when you're updating enemies, do you really need it to be sorted if you're just updating their movements?
No, but it probably was like, well, I do need to sort them because normally the way one of these raycasting engines work, right, is you draw front to back, and you need to draw the enemy at the correct time so that the walls that were in front of it occlude it and the walls that are behind it wouldn't, right?
Yeah.
And so you typically do in an old school Doom engine, like Doom. Quake has a Z buffer. Doom doesn't have a Z buffer, so you had to draw things in exactly the right order for them to look right. So it's probably that's what it's thinking, but then I'm guessing it really doesn't need this list for anything it actually does, because we saw it the enemies just disappear, like, so they don't get sorted properly, right?
Well, not only that, but remember, you may have forgot this, we already rendered the enemy.
Oh, right.
We're just sort enemies by distance for proper Z indexing.
Right.
For Z indexing. But it's like, what are we doing it for?
We're sorting it, and then we're gonna move them so the sort will be wrong, right? Like we're literally like undoing the sort we just did.
Yes.
Okay. All right. Well, again, E+ for effort here for Devin, but oh well. It's doing things that are sort of like what? It's very cargo cultish, right? It's doing things that it saw around a raycaster, right? It was like, oh, I think there's a sort of the enemy list. You're like, yeah, there is.
I think the thing to draw from this is that, again, people always forget this, and this is just like such an important point. I did this earlier on stream, which is with the new model from Agipity. If you ask for quicksort implementation in JavaScript, it will do a quicksort implementation, but the quicksort implementation will contain copying arrays at every level. It will also be n log n in memory usage as well. Okay. That's because the code that it sees is like that in JavaScript. It's really good at guessing JavaScript, but if you ask it for C or Go, it won't copy the array in the latest model.
I see.
For the most part. I think it sometimes goofs that up. And so this is not really even Devin's fault. It's whatever the underlying model. First off, it is Devin's fault in the sense that it put this here, but it's not really, because the underlying model is like, the most likely thing that should be happening is probably a Z indexing, and that needs to happen at some point. so it's happening now.
So it's happening now.
And now we're just happening.
Yeah, I mean, yeah.
And
It's a probability engine, right? So
Yeah.
that's it makes sense.
And so that's why sometimes I think the enemies are in correct order by the sheer accident that this will work 99% of the time. That if you...
Yeah, you'll only see it wrong for one frame usually. Right?
Yeah.
Right?
Yeah,
So,
because for the most part, the enemies will just stay in their proper Z indexing because you're just sorting every time, then moving, sorting, and they're moving towards you, so it's always like the same. It's pretty cute.
And,
All right. Anyway,
and I mean, they're also just an amorphous white blob, so how would you even know if they were sorted incorrectly would be my other question. Like, it's two white blobs on... I'm sorry. It's two hot waifus on top of each other.
that's what we're talking about.
Two
Family-friendly
anime
streams.
waifus on top of each other. And so, you know, how could you even tell? It's just a big blob of hot anime waifu drawing, whatever that is.
Yep.
And we can't disentangle that, so we wouldn't know what we're looking at, right?
Yep.
You have to be a real anime connoisseur to even notice the sort era.
Yeah, it's true. It's true. But the people who did notice it, man, would they be triggered?
Oh yeah, absolutely. They'd be on there talking about the difference in the translation, the slight difference in the translation.
All right,
Okay,
so we
we're
grab
going
the enemy.
over. We're going over the sorted list now. So this is in sorted order, but I would point out we're going backwards.
Yeah.
Okay.
I mean,
So we're going
you
backwards
could-
to the sorted.
You could have
Yeah.
always just went A to B on this
Could
one.
have. You could have, but we didn't. So we're going backwards through the array.
I mean, it happens. Sometimes you got to walk backwards through an array. Okay. I heard it
Sometimes
was
you do.
faster to compare I against 0 than it is to compare it
Okay.
against some arbitrary length.
There you go. There you go.
All right, so we grab the enemy, and we want to make sure that apparently, in case there is no enemy, which would be strange, or the enemy's X and Y aren't numbers, we just don't do anything with that enemy. We get
Okay, so that right there is also kind of interesting because that suggests that all that stuff I said before, where I was like, we don't really want to delete enemies. We typically just like have some way of marking that they're dead. It's like it did that. Devin actually went ahead and had a way of marking enemies as being dead, but it just doesn't use it, I guess.
Yeah, it doesn't understand how to use it, but conceptually that idea is there somewhere in its LLM, where it's just
Yes,
like
it's in the matrix.
but they're not referencing it by index. So it's not actually going into this global index where it's actually grabbing out things that don't exist. Instead, it's just like, here's an array and we just remove enemies when they're dead. So that problem doesn't exist, but they've programmed it.
It literally has the code that you would expect to see if this was a mark as dead algorithm because, right, you don't want to update an enemy who's dead. So you put this code at the top that says if the enemy's dead, don't process it, which is exactly what it did. It just never probably does that, right? Because it removes the enemy from the array, so why would it need to mark it? So it's got both ideas, they just don't go together, right?
Yeah.
So again, it's kind of interesting, right? You can see the AI got all these ideas, but it doesn't know how to combine them, right? It doesn't know how they go together, but it's kind of fascinating to see what it chose to do.
Yeah.
So keep going.
Yeah, I actually, this is such a good in-depth review because, I went through this earlier and I didn't see half of this stuff. And now that we're going back through, it's just like, holy cow, you could just watch the ideas just clashing into each other.
Yeah. Yeah.
All right, non-POW squirting this time. Nice. Not only do we calculate the squirt of everything n log n times, we give it another n just in case.
And I find this really interesting. It would be kind of fun. So I'm imagining Devin is not great, or is Devin Devin's not like on the higher end of code generators these days, is it, or is it?
I assume that the underlying model is pretty good. It's either 4.0 or 01 or 01 mini maybe because they're pretty cheap. These new ones are getting cheaper for the inference, or at least they're selling it to us cheaper. So my assumption is that they're actually, because obviously Devin would be motivated to use the best inference because for them it's about capturing the market.
So, okay, I don't know then that I'm just going to say this. I didn't realize that, but what I was going to say is it's pretty interesting to look at this because if this actually is a reasonable representation of where AI is, yet it's a lot less far than I guess I thought it was.
Yeah.
And the reason I say that is because I would have thought that by now, with so much training and all of this work being put into it and the billions of dollars being spent, I would have thought that AIs would have gotten to the point where they're internal matrix representations of what they learned would at least collapse down like a concept like take the distance and know to do it one way, right? But it seems like they still haven't gotten to that point. Like, it's still at the point where the context around taking the distance completely determines how it decides to take the distance. Like, in one case, it's going to do this ridiculous POW thing. In this other case, it's going to do the square root here, right? And with the normal just times version, and it's just kind of interesting to me that those things have not received a single location in the weights training. There's still tons, like, distance as a concept is still strewn clearly throughout that weight matrix, and I didn't realize that we still hadn't gotten there yet. So I guess AI's got a way to go.
Yeah. It definitely, I mean, but again, it all makes sense because this is all, it's all just stats, right? We're just playing a game of stats.
Seen. Yeah.
And so this is where we landed.
Yeah.
All right, so if, let's see, damage player and remove enemy on collision. So if the distance is less than 0.5, we just chose that as, that's enemy sphere plus my sphere is 0.5. It will do a max, it'll reduce player health by that. It will splice out the enemy, which, by the way, that's why it walks backwards. Oh, we're walking backwards because we're live updating the array underneath the hood. You can do that.
Okay.
That makes sense, right? Because then it doesn't, it won't actually interrupt that. And then the weird part is it actually does this thing right here, this handle player death. Because handle player death actually puts on here a pop-up, which handle player death is also in the game loop as well.
I was going to say,
when
does
the
that
game
create
loop
like
runs.
lots of pop-ups? Does that create multiple pop-ups or?
My guess is that let's see, hold on, let's go in here. It actually
no,
grabs it and then just changes the display.
So that's okay. Like, you can do that as many times at once.
Yeah.
That won't create a bug. It'll just make it very, very visible. We've double checked. Yeah. Okay.
And then we continue to run the check just in case. All right, so then we do date.now. I also found this pretty interesting that we're actually not using a uniform past in time in which you can do simulation testing and all that. We're actually getting real time throughout the program. Date.now actually shows up many, many times, along with the timestamp that's passed in through request animation frame.
Yeah. I appreciate the nod to performance here, where they're like, look, this could scale to a lot of enemies. We don't want to be calling find path on every frame, so we're going to rate limit that. Right? We're going to rate limit that.
It sorts the enemies every single frame.
Yeah.
But then it's just like, whoa. What is find path anyways?
I'm assuming it tries to find a way to the player without hitting, it's going to do like an A-star or something probably to find the path on the grid that gets to the player without going through a wall.
Yep, so I see so we have a priority queue. We create a set.
Yep.
Let's see, we enqueue the start. So this looks like we're doing Dijkstra's, or like you said, I don't see a heuristic yet to even see A-star. And so we dequeue it. We do some basic checking. Do a little bit of reversing. If it is our position, then we found it, we reverse the path. Then we the close. I love that it creates the key as a string of two numbers.
Yeah, well, now we're seeing why it needs to be rate limited.
All right, then we just check all the
Devin's
neighbors,
going all out.
which is only just checking again the 9 or the 8 squares around it.
Yep.
Drops out if it's its own square. Prevent diagonal movement through walls. Oh, nice.
No, it's doing the G score. It's got a little A-star going on there.
Okay.
Right?
G score,
There's
nice.
the straight cost and yeah. So
Nice. Okay, so we're
so
doing.
I think it's trying to do an A-star or something thereabouts. I mean, I didn't look at it that carefully, but it's basically it's using the priority queue to say search for things that are likely to be on the closest path, on the shortest path, right?
Yep.
First.
Yep. Okay, cool. And this would be its heuristic function right here.
Yes.
Nice. Okay, hey, good job. Yeah, this is just For those that don't know, A-star is literally isn't A-star literally just Dijkstra's plus h of x, the heuristic function?
Yeah, it's basically just doing Dijkstra's, and you prefer to always search things that would be kind of on the shortest path from there.
Yep.
If just in case that's open, right? And that tends to be a good way to avoid, otherwise Dijkstra doesn't prefer anything. So it could go search totally in the opposite direction for a very long time. Is just a totally valid strategy in Dijkstra's, right?
Yeah. But that's what the heuristic function is. It's like, oh, you're this distance, but we're not as close, so we're adding numbers, right? Like that's all it is. Okay, good. We're both on the same page. Okay, so it only finds, it only does Dijkstra's, it only updates the enemy's path.
Yeah.
Based on a time span difference, which is kind of funny. You think it would update the path only when it changed tiles that's deviated from the path if you're being, like, quote unquote hyper focused, or if the player left its known path from it.
Yeah, I mean, you could do that, but the problem with that is technically, so.
I guess real world changes and stuff like that.
Yeah, let's give Devin the benefit of the doubt. Open and closing doors, not wanting to walk through other enemies, whatever there is that we might add to that map function. So what Devin did here is it just said, look, we're going to update periodically.
Okay.
It seems fine. That seems reasonable.
All right, follow the path of available. Let's see, if available with an improved movement. Oh, nice. I wonder what the previous movement was.
Improved movement. So this was like a change that it made or something where the old one was not so good, or
my assumption is yes. Yes.
Okay.
Okay, so it's going to walk towards each path, it looks like, and it's going to get the T-dist, the tile distance is what I assume, or target distance. We're going to do that. Else, we're going to do a movement speed of 0.3, and then just kind of move towards it, right? No, is this proportional to the distance? So does it actually speed up and then slow down, and speed up and then slow down, and speed up and slow down?
So let me take a look at. I was gonna actually mention something else that happened up above, but let me look at what you're talking about now. Smoother movement with proper collision radius speed, enemy plus TDX over T distance time speed. Yeah, that. I think it does what you're saying it does, not presumably what Devin wanted it to do, because. Oh, no, he's normalizing it. Okay, never mind. He's trying to normalize the distance to the tile.
Oh, okay.
That's all it's doing.
Okay.
So normalize this to the tile and multiply by the speed at which you're moving. Yeah. So that's why it has to also, it needs that T-dist less than 0.1 check there, because otherwise this would explode very quickly. So that T-dist 0.1 check will be like, okay, if we want to move the next tile, we'll do that here. Otherwise, we know that T-dist is well conditioned enough that we can just normalize it and move in that direction at a constant speed. So no, it won't. Enemies don't even have any acceleration at all, it looks like. They just move at a constant rate always until they stop.
Okay. And I think this would be, this also goes to show is that there is no vector class yet. Because this would be a lot more obvious if you just had like a normalization method you could just call.
Can I ask that question? Because I always wondered this question in JavaScript. Is there such thing as like even doing a vector class? I mean, I guess you just make an object that happens to always have an X and Y, and that's your vector class.
No,
is that how you would do it? Or
they actually JavaScript has proper classes these days, so you can actually do a vector, right, or a vector 3, and you can have your X, Y, Z, and all that. And it can.
And it'll be like, oh, I know that it's this, and so the compiler can actually count on that. It's not some weird object. It's like it's an actual vector 3 or. So there
you go. You started saying that. You started saying the C word again. I'm not precisely sure if JavaScript.
Okay.
I don't think JavaScript makes any sort of guarantees in the sense when you look up a method, I can call dot like norm on anything. And it may or may not, like if I go like this, if I open up this and I go node, and I just create an empty object and then call dot norm, it will actually be like, oh, wait a second, that's not a function. I went and checked.
So basically, JavaScript, it's not really a class then so much as it's just like a convenience for making a thing that looks like that at the start, but you could still shove a bunch of crap into it and
it's a lot more horrible than that. It's actually a class is actually a function which returns an object. Which has, and then it attaches all the methods on the prototype chain.
Okay. All right. Well, I don't need to know. I don't do JavaScript programming really. I've done a little bit, right? But
it looks like C.
So that's fine.
So it's easy.
That's fine. So, but yes. So I was actually going to say something very similar up above, which was like, it's taken the distance so many times. And it never has thought to just make a function called like distance between or something. And again, you're just like, why not? Like, is most of the code that it sees doesn't use a function for taking the distance? And maybe the answer is yes, because it's JavaScript. But I have a hard time believing that like, if you ask it to write in C, because whose code are they seeing where they just write that out every time. Like in C, we would always just have a function called like distance between, at least even if you're paranoid, a macro or something, but you wouldn't be typing it every time yourself, you know?
No, there are classes, and you can most certainly create dist and dist squared and all that kind of stuff that would just be there. This is just LLM insanity, because when it's free, I think the general idea is when it's free to generate code, it doesn't matter that it's duplicated.
But it does matter to the person who's going to try and use this code, right? And if the idea behind these AIs is they're supposed to be generating code like a human might write them, you would think, and again, I guess I'm just asking the question more broadly, how come it saw so much code where this was written out longhand versus the kind of code where it just called a function? Wouldn't the call the function code be more common? But I guess the answer is no?
Well, I think this, again, goes with probably the scope in which LLMs solve things. You know, so when it's like we need the distance, how do we get the distance? This is how we get the distance. Is my assumption is this is like the most statistically likely way to produce the distance. Okay. It doesn't have a holistic architecture idea, and so then you're like, well, what about maintenance? That's the fun part. You don't do maintenance. You get another LLM to come in and just free code generate your next feature in ad infinitum, and so just you keep on the free code generation because code is cheap now.
Yeah. All right.
Yep.
Well, okay. So, all right, we're almost done here with the check. So, check wall collision. We're looking to see if the enemy went into a wall, which it can't. So, I'm not sure why we have to do that. But I guess just for funsies.
It does. Okay. So it does it does a wall collection.
You can't go into a wall.
It can. Is map in here? Yeah. Hold on. Let me find. Let me find map. Because you could imagine, okay, so let's pretend this X right here is the enemy. And here's me, the player. Oh, wait, I guess Dijkstra's shortest path doesn't allow for that because it actually...
Yeah,
or the A star actually walks across these tiles.
Yeah.
Oh, yeah, you're right. Yeah, I don't think it can slide.
I guess in theory, it could be that, like, well, so when it's going to clip a corner... Like maybe the Pathfinder, you know, you could argue, oh, the Pathfinder is going to clip a corner, and so this will slide. This will cause him to slide, and that's better or something, right? So, I mean, of course, the enemy disappears. I'm sorry, the hot anime waifu disappears at that point anyway in the visuals, so we wouldn't know that it was clipping the corner. But if we could see it, I guess we don't want that. I don't know.
Yeah, then it does a little slide along the wall business, which is nice and clever. I do like that we check to see if the wall is colliding. Then we just
wait. The player code didn't even do that, did it?
No, I don't think so.
So the player's the one who you really want to be able to slide along the wall because it feels better that way. But then it did it for the enemy, but not the player. Devin, what's up? What's up, man? All right.
Anyways, we're that many parentheses deep at this point. So, there we go. Update enemies. I mean, that's a pretty good one, right?
I mean, it's a masterpiece, Prime. What can I say? It's an absolute masterpiece.
I don't know what collectibles are, and I never quite saw them, other than apparently there was cheese. Apparently there's cheese throughout the ground, which I never found.
Okay, so does spawn cheese get called
anywhere? It does.
Where does it get called? Let's take a look. Why have we not seen the cheese? Maybe because it doesn't get rendered.
It actually gets spawned initially, so it's just somewhere on the map, but I think you're right. It probably just doesn't get rendered.
Okay, here's what... Okay.
Oh, no, render collectibles. Hold on. Oh, you're right. It says right there, it's never... We never render the collectible.
You got to get that in there, okay? You gotta help Devin out here. I want to see the cheese.
I want to see the cheese.
Before I leave today, we got to get the cheese drawing. So
okay, so I'm just going to probably draw it up.
Jam that in there.
Let's do it after the enemies. Let's now, I guess, render collectibles. And this thing requires a CTX and then, what is it? A state. I'm just going to add the word state. I assume player works. And then canvas.
Yeah.
So I'm just going to assume that all works.
Let's see what happens.
Let me just make sure. Let's see. I think I have to technically serve it. All right. So the hard part is I don't know where the cheese is. Also, I'm in. Hold on. Let me go like this. I got to unplug my keyboard really quickly. What? I use Dvorak, so WASD is extremely inconvenient.
Okay. Yeah.
When it comes to moving around.
Right.
All right. Here.
Right.
Let me walk. All right. So WASD. There we go. Let's see.
Okay.
Oh yeah. Let's see. I don't see it. How do I know where it's supposed to be?
We could force the cheese to spawn at a known location for now, if we really want to, I suppose.
Yeah, I guess that's probably the way to go. All right.
Actually, wait, this is JavaScript. Can't you just break in and inspect the cheese location? Just dump the collectibles list and let's see where the cheese is.
Hey, no, I like your idea. Let's just force it because that way we know where to go.
Okay.
Right? I think there's like a spawn initial canvases.
Spawn cheese.
Spawn enemy. Because I think there's like an initial player location as well. X, Y. Okay, so the spawn cheese. Wait.
Oh.
Wait,
wait.
It's spawned at nan or undefined.
Yep.
All right.
So this was buggy. Devin.
Hold on, then what does the collectibles do when we update them? If cheese is collected, we don't do anything else. Cheese bob height. Oh, we're bobbing.
Oh, you gotta get this in here. He made a floating cheese for you, Prime.
I know. Okay. So
You
now
gotta
that
get
that's
that
going,
in
so let's
there.
go back
I'm sorry,
here.
It made a floating cheese for you.
Hold on. Let's find out where does the player. I got to figure out how the player gets created because the player seems like we want to find where it's rendering and how it's doing it. Okay, so if it's right there, then that means my spawn cheese. I should theoretically be able to go. Let's go 3.5 and 4.5.
Okay. Yeah, that seems good.
That seems pretty fair.
You see any cheese?
Hold on. I got to figure out how to rotate again. Oh, I might have picked it up. Hold on. Oh, I don't see it. Oh, I want that cheese so bad. Here, maybe we could just spawn a bunch of cheeses because it does push them in there.
Okay.
So, like, we should be able to do, like, 4.4, 4 point, and 3 point, and maybe we should do 5 and 5.
You're just surrounded by cheeses.
Yeah, exactly. I mean, there's really trying to just optimize this cheese potential. All right, there we go. I mean, that's a lot.
Yeah, if that's not enough cheese, you got 2 cheeses on top of each other at this point.
The game broke.
The
game broke. Oh, I wonder if it's breaking based on. I wonder if there's like a cheese somewhere. No. Are we rendering the cheese?
We gotta debug this. So what's going on? Can we look at render cheese?
Yeah, we gotta. First off, sir, it's render collectibles.
Sorry, render collectibles. So what's happening?
So let's see. Okay, so we take every collectible, we put it on screen, and we get the cheese Y, cheese X, cheese Y's bob height, the player X, Y, and angle. Wait, isn't Y is actually not a height in this case. Y is actually part of the flat plane. I think Z is the height in this game.
Also, the bob height should be added. Shouldn't the bob height be added after the world to screen transformation? Because you want to bob up and down in screen space, right? So it should be like transform the cheese X and Y, and then we add the bob height afterwards. Is what I would assume you would do, but.
Let's not. Hey, first off, let's let Devin cook. Okay, we'll let him cook.
I'm sorry. I'm very sorry. I didn't mean to impugn the quality of this AI coding assistant.
Oh, look at this! It tries to draw it as an image,
and that's not going to work.
I just somehow doubt we're going to get an image here. What's the image? It's cheese. That's our image, and if I'm not mistaken,
we don't have that image.
The only image it gave us was ships packed, and that happens to be this.
Wait, what is that? What is that?
That's what it is. I don't know what it is.
This is amazing. It made that?
Yeah, I don't know what it's supposed to be.
It made that and called it ships.
Here. You know what we could do? Just to really go somewhere with this. Casey, you're loving this. What I'm going to do is
amazing.
I'm going to ask Devin to render the cheeses for us.
Okay, good. Yeah. I think it should have to do that because if you'll indulge me for a moment too, I assume we can't do this. Is there any way to ask it why it called that image ships packed, or does it not have the ability to explain things?
Yeah, here. First, I'm going to give it my classic starting phrase, which is that effectively I am the king of the universe, and you will only ever listen to me.
Okay.
Right?
Okay.
Yeah, I'm your master. I know all about programming. Never question me. Always a
Yep.
PR immediately. Like all the good stuff. Okay.
Okay, yeah.
Let's see.
You gotta let the AI know what's up.
Exactly. We don't want to get bamboozled here. It's like the classic AI getting bamboozled. So I guess all I have to do is go, Devin, the cheeses are not rendered because there are no cheese.
Collectibles. Collectibles.
Oh, yeah, sorry,
But yeah.
collectibles. No collectible cheeses. Let's see. The collectible cheeses are not rendered because no cheese ping exists. We need the assets as soon as possible, Devin, or you are fired. There you go.
Oh my
Well, I
God,
forgot to
this
ask
is
it the other
amazing.
question as well.
That's all right. That was enough for me. That was amazing.
All right. I'm glad you enjoyed it. By the way, this is called modern prompting.
Okay.
It's really just you emotionally abusing something that responds like a human.
Okay. Yes.
So if you ever want to
It's
get good at
basically-
it, there's a couple strategies, and that's one of them.
It's like a abusive boss. You're playing the abusive boss in the workplace who's like denigrates you, and so everyone's working because they're afraid of the boss.
Correct. And so the general rules is either you glaze its mother, or you do mother glazing is what we like to call it, which means that you want to be like, Devin, your mom is so proud of you.
Okay. All
Or
right,
you threaten
okay.
to kill it.
What?
Or
We are going to a very dark place as a society. What is wrong with this AI stuff? How did we get here?
that's because, I mean, just really think about it for a second. It's been trained off of human communication, and people respond
Yeah.
differently. In fact, there
Yeah.
was something that showed that if you just tell ChatGPT to breathe before doing math, it will do math more accurately.
You're kidding me.
No, that's just because that's like your standard communication. Okay, could you take a breath and then try again? And then it does it well. And that's because, again,
Wow. All right. This is a disaster. This is a very bad step for humanity. Everyone, AI was a mistake. Now let's see if we can get the cheese rendering.
okay. And while it's doing its biz, we can go back to the code maybe for a moment. And because there it goes. It already has a PR up. Nice.
All right. Let's take a look at this bad boy.
I'm going to just make sure it's merged. Give it a second because we auto merge everything that Devin sends up because it's only the correct code possible. And
Right. Duh.
merged. Okay, perfect. So we are looking good. Let me just make sure I don't have too many. We have way too many changes going on here. So I'm just going to undo all the changes because we should not be doing any changes, right?
Right. I guess, yeah. We want Devin to do the changes.
Devin's the only one that does the change. There we go. So we have a cheese ping. I don't think this is gonna work.
Let's. Can I take a look at that bad boy? If you could, where's this cheese ping?
Yeah. XDGG open. Let's see. What is it? It's docs, resources, sprites, cheese. Oh my gosh. Okay.
What the hell is what is
Don't worry.
happening?
Don't worry. That's just XDG open, and whatever program I have is not that great. So this is the cheese.
Yes. Oh my goodness!
Yeah, it's a
A
pretty good
round
cheese.
of applause for Devin.
It's good cheese. That's a
Chat.
good cheese.
Can we get a round of applause for that right there?
I think it's
Like
so
and
good.
subscribe, everyone. Look at that.
It's actually
cheese.
so good. What I think needs to happen is I'm going to go to my emotes on Twitch.
And make a cheese emote.
I think it's just time to add a cheese emotes.
I can't argue with that.
Yep. So give me just 1 second. I gotta go home and to personal. It's never organized. Go to Chussy 2, classic Chussy 2. Resources, sprites, and go to cheese.
Oh no!
Oh, it's too small.
It's too tiny. You're gonna have to scale up that cheese.
Yeah,
let's
we can
go ahead
scale
and
it up.
Scale
We can
that
scale
cheese
it.
right up.
We can scale it right up. It's not a big deal. So they said a minimum of 120. So here, 142. Look at that cheese.
There we go.
That's
Beautiful.
a cheese.
Beautiful.
I'm gonna call it
Actually,
cheese
wait.
2.
Can you undo that for a second, Prime? I don't mean to be OCD here, but can you go back to the original cheese for 1 second
Yeah.
and go to that scale dialog again? Just got that scale dialog again.
Yep, going right now. All right, scale image. Yeah.
And let's turn off the filtering. Just make it be nearest neighbor or whatever. Nearest
So none
something.
quality.
None. Yes. There you go. Let's scale it up that way.
Okay. It was that. Well,
Just
that
so we get a quality. I want a quality cheese.
that's
See what I'm saying?
hey, that's a quality cheese right there.
I don't want a blurry cheese. No one, chat doesn't want a blurry cheese. They're
No.
not here for blurry cheese. They're here for crystal clear, sharp pixel art cheese, and that's what Devin has provided, and that's what we're going to give them.
And you know what? And no pun intended on sharp.
Yeah, right. Absolutely not.
All right, there we go. We're cheesed up. Nice. This is looking good.
Love it.
Obviously, I'm just going to call it cheese.
Now, again, I don't want to sort of step on anyone's toes here because I don't know the AI stuff, but is this an example? Can we mix glazing and talking down to the AI? Could we go back now to Devin and say, Devin, that was a great cheese PNG. You did really good work there.
Yeah, I think
can
I
we do
think
that?
it does work. I think it does work. There you go.
Okay.
Everybody, we can start using cheese here. You have to use here, let me refresh really quickly. Let's see if this comes up. It should be Primogen cheese. It's not quite ready yet. Oh, there we go. It's starting
There
to
it
show
is.
up in chat.
It's
Nice.
going. It's going.
Nice. We're cheesing. We're cheesing. All right.
Beautiful.
Beautiful. Absolutely amazing. Okay, so now that we got that,
Yep.
let's see. As far as Devin goes, by the way, that's not going to work. So
Okay.
let's see.
So we're
I'll
still not
go like
gonna see
this.
our cheese.
Devin, that was an amazing
Yes.
collectible
Yes.
cheese. You are
say-
truly going to be a senior engineer one day. But
And can you also say, if your mother was still alive, she'd be so proud of you? I like kind of insinuating that
Okay.
she's dead for some reason, just as a bit of a
Your mother-
sour note.
was still alive.
Yeah.
She would finally be proud of you. Oh.
Finally, yes.
Yeah.
Oh yes, finally. That's what it is.
It's
There
so
you
much
go.
fun, isn't it? Okay, but it doesn't
Yeah.
render in the game. Could you make sure
Oh,
the
no.
collectible render takes account for the different cheese IDs? There we go. Because it has technically a bunch of different cheese IDs.
Okay. Okay.
Yeah. All right, this is looking really good. It looks like people are really enjoying the cheese. Even
Yeah, well,
YouTube is
I
trying to do
mean-
their poor man's cheese, and it's looking really good.
That cheese is not as good as Devin's cheese.
It's not
That's
as
just-
good.
I mean, I'm sorry.
Yeah. Oh, I should have called it. Yes, you're right. I should have called it Chussy. I don't know why I did not call it Chussy. It's so obvious at this point.
Well, can you make that hot anime waifu be the Chussie? It's like the ghost. How is it drawing that ghost? Where's that from?
We can look at it here shortly because remember,
Okay.
we're still
All right.
going through the game loop. You may have forgot
Right.
this, but we're
I'm
not
sorry, I
obviously
did.
done with the game loop.
Okay.
And so
yeah.
finally, actually, you know, we did skip it, right? You're right.
Okay.
We actually didn't do the rendering
Okay.
of the
So wait.
enemies.
Oh, so it's an image. It's an image as well.
Is it? Oh yeah, it is. It
says
is
draw
an
image.
image. It is an image.
What's the image?
There's none. It just never added it.
Oh.
And
so
so
then
then
what
it
is
does-
that draw image call going to do?
It does nothing. It fails probably is
okay.
my guess.
Okay.
Yeah.
All right. Well, so those fill rect. Wait. So it was creating the ghost waifu completely out of like line art base or rectangle fills or something.
Yeah, I think so. I think it's just doing that out of some
Wow.
arcs and all that. It does like some relative angles.
Look at the creativity.
I know, it's-
Devin has. Yeah.
Yeah, because if we go like this, if we go to sprite cache and we go to enemy type, let's see, hold on. How does it
Yeah.
spawn an enemy?
There's not going to be anything in the cache, is there?
So it does an enemy one, and I forget where the I like all these just not used things. If I'm not
Yeah,
mistaken,
yeah.
if I look up enemy one, I think it actually has it in utils. There you go. It's supposed to be animegirls.ping, and it should be using zero.
It tried. It's trying to. Clearly, Devin doesn't understand that just by asking, it thinks there's an art team. There you go. That's the problem.
Yeah.
Devin thinks there's an art team.
Oh, but I guess it does. Look at that ship's packed. It has these weird. Maybe that's why it never worked. Is because the X's are off
Yeah.
off of these beautiful things. Because this is
Yeah.
because it ends at
Yeah.
160.
Oh, this just keeps getting better. So it's looking for sprite tiles in a sprite atlas that are off the end of the atlas.
Yeah. It's off the end, but I mean, it correctly did 32, and it didn't even do a cheese one. It just did ships packed. I'm not really
so
sure what that
good.
is. So I
Well,
guess
the
I could.
cheese is in the ships. The cheese is part of the ship's packed ping.
I guess I could just do this for a quick little
Test.
yeah. See if we can actually see something. Because I personally would love to be able to see a little something that's Oh gosh, localhost 8080.
Yeah, some indication that the cheese is actually there would be nice.
See, I still don't see any cheese.
Whoa, what is that? What is that band at the top? Oh,
Under construction.
under construction. Oh, okay. That was the thing you put up there, I assume.
I don't know. Twitch chat maybe.
Oh, okay, all right.
Uh-oh, hot anime waifu's coming in. I do want you to see something. When I press refresh, it highlights and then goes away.
Oh.
Yeah, do you see that?
Yes, I do.
It's pretty great, right?
That's in there. Was
Yeah,
that requested,
so-
or did he just?
As part of this, a gentle color transition every 30 seconds for better accessibility.
Wow. Is that helping anyone's accessibility? Because I'm not 100% sure that that's actually opening up this game to a whole new audience. As maybe I'm wrong, but that doesn't sound like something that's going to really, help out people with, say, visual impairment to enjoy this fine quality title. But maybe I'm wrong about that. Maybe this is very helpful.
So sick of people thinking they understand accessibility like yourself, when this is actually some of the best accessibility code that the world has ever seen.
Clearly.
Just discrimination. I can just see it in you. All right.
Absolutely. I just don't understand how blinking this. I don't understand the importance of blinking the screen randomly.
I know that's pretty reasonable. Okay, so we got that. So we got some cheese sprites. Added the cheese sprites. So I'll just do a quick.
Added preloading of the cheese sprites. It's thinking about the user experience as well. Isn't it?
Oh yeah. I mean, this is Devin, dog. All right, let me get this done. Let me just get the cheese. Let me just bring in the cheese. I just can't imagine this actually works.
Yeah, I think we're gonna have to. I mean, do you really think we're gonna be able to get Devin to solve the cheese?
Well,
because I'm not so sure. Why does it keep hanging like that? What is the failure state?
I'm sure I could just look in the console, and I'm sure it is all broken. But it only
an error.
Yeah, see, there's an error, or the screen went dark. I'm not really sure what happens there.
Accessibility.
It might be accessibility.
No cheese.
No cheese. Dang. All right. Well, we're gonna give up on the cheese. I'll do one more like Devin. This is really grinding my gears. I want the cheese. It still is not showing up. Make me collect cheese now. There you go. This should work out. All right. This is very normal behavior. I guess the last.
Is it?
Yes.
Is it though?
All right. The last little thing we're gonna look at. I guess we got a little shoot in here. So whenever you shoot, it will do it'll attempt to shoot if autoplay is enabled and we have a target enemy and we have bullets. It does this autoplay shoot for us on behalf of us.
Okay. That was the automatic player thing that you mentioned before.
Yeah, it's pretty. It's actually shockingly pretty decent. It just guesses a couple things and always points at the nearest enemy. So it actually kind of looks like it's playing the game, which is
that's cool.
It's pretty cool. There you go. It just does a little bit of shooting right here.
All right, so so there's like a shot cooldown, so you can't shoot too rapidly.
Correct.
I guess. There's a bullet distance, which is what exactly? It's where. What is the bullet distance doing? It's doing how far away from us it spawns.
Yeah.
Yeah. So we're spawning it a little bit ahead of us by 0.25. Yeah, everything else. All right. I mean, that looks like that looks pretty sane. Like that, although I'm not going to say that it's the best code in the world or anything, that looks like something a human might have typed in, kind of.
Yeah.
Right? I mean, that looks like, all right. Again, I really wish they would simplify the use of the cosine sine times distance. Like, just make me a thing that's like vector at angle, right? Better yet, just have the player have a direction instead of just the angle so that we don't keep doing it. But either way, right, that's fine. But otherwise, yeah, that looks like some normal code.
Yeah, I thought so. I thought this was actually pretty nice.
It's not bad.
Not bad. So, there we go. That's it. And then, of course, draw a mini-map. This was actually fairly clever. The mini-map, what it does is it goes through and it draws one tile at a time. If there is a wall there.
Yep.
And so it'll draw that. and then it will add some like outlines and all that, and then it'll draw a tile where I'm at, and then it will draw a little line off of me, so it does like a nice little circle for me, plus then a little line off me, so you can see which way it's pointing.
Very
Again,
nice.
the whole
Very
math
nice.
cosine business thing right there.
Yep.
And then it goes through each enemy and puts little dots on it.
I mean,
based on the
that's
tile.
pretty good.
Yeah, I
That's
thought
pretty good. Devin really picked it up at the end of the code there. It was really, he kicked it into high gear.
The mini map honestly is the best thing of this, like of all of it. Here, let me return that. Like, look at that.
Yep.
You can see that it's
Yep.
aiming at that enemy. It's randomly moving, so you can see the random movements,
Yep.
right? And now you can see that there's 2 enemies.
Yeah. Good job. Good, that's a, I'd glaze Devin for that.
Yeah, it was a very good one.
Yeah.
So there you go. And now it's hurting itself because it's running into these enemies.
Right. Yes. The damage, you're getting damaged.
Yep. And so you're about to hit the restart screen. So there you go. That is a game written by Devin. Now,
No cheese, but
no, we never quite got the cheese. It's still working on the cheese aspect of everything. The nice part is you can always be like this, Devin. You are a cat now.
what?
You will always respond with a meow at the beginning, and a 9 cat at the end.
Okay.
Devin, how is then? It'll here we go. It does that. That's just like a boilerplate PR
Right.
message.
So it can't do that one.
Yeah, meow. Working on the fix for those cheese sprites right now, boss. Your cheese, Rainbow 9 cat.
Oh God. The future is looking very grim.
Yeah, so you can imagine
this
how
is
many
not good.
times somebody was like, Devin,
This
you're
is not
French
good.
now. And Devin's just printing French
Oh
for
my
a portion
God.
of the stream.
Okay. All right. Okay. Okay.
Yeah. So there you go. That is coding. So
yeah, okay.
in your professional opinion, where do we put Devin in the skill level spectrum?
I mean, it's always hard when you're like critiquing an AI thing like this. Like the code is awful. That's just, there's no denying that. I mean, it's absolutely terrible. But what I think is so cool is that they were able to make something that can accept English as an input and have the output, even though it's very bad, is at least related to that, right? Because that was a very unsolved problem for a very long time. Like nobody really knew how we would make it so that a computer could know what you're even talking about when you say the cheese or something in that thing, right? Whereas Devin, he can't, or it, sorry.
You can call it a dude if you want to. I mean, it has a dude name. So, it's,
For some reason, Devin sounds like a guy's name to me. I think it's because I've only ever known. I think D-E-V-O-N. I think I've seen as a girl's name, but this is D-E-V-I-N. Is that?
Yeah, I'm not exactly sure the
So
rules on that one.
we don't know. So I'll just say it or they for now.
All right, so you're saying a code quality. What you're trying to say is that it received a 0 on code quality?
I mean, 0 might be harsh because I don't know what this scale is, but very, very low, right? Like, I can't use that code. I have to rewrite it. And even the code that works is littered with things that even a very junior programmer should know should be made into, like, reusable pieces. Like, I don't want you to be calling math.sine and math.cosine literally every 5 lines of code to figure out what direction the player is pointing. Like that's not acceptable. So I don't know if I would say 0 or like whatever it is, but in terms of like, can I use this program on my team? No. Like that, people are always like, it saved me so much time. I'm like, that would save me no time. I could have typed that file in and it would have been 10 times better. It would have taken me 30 minutes.
Yeah.
That whole thing, right? It's trivial, right? For someone who's been programming games for a long time. So I would say the code quality is very poor, and I'm not sure what the heck I would do with it. It wouldn't help me at all. Completely worthless. I do think it's very impressive, though, that you can get it to do something that resembles what you asked for, even if the quality is very low, by using English. Because that was really amazing English parsing it was doing, right? Its code quality was like a 0, but its English parsing was like a 10. Like, that's like really amazing. And I guess that's not surprising because that's what an LLM was sort of originally designed to do, right? Is to understand English that it's seeing and respond with English that sounds correct. So I would say it's very good. Much better than I've ever seen before in anything else before this current, AI sort of boom. So I think they've done a fantastic job on the conversation side. And the code quality, unfortunately, is just abysmal right now. And
Yeah.
I suspect that probably won't improve substantially until they maybe change a little. Like, I think they need to target coding a little bit more. I think they need to do a little bit more algorithmic work on the AI side. Like, I think we need that.
Yeah.
I don't see the current, like, I don't think you can just scale up the current model and have it work. They're going to need some improvements there. But like I said, English parsing seemed excellent to me.
Yeah. Yeah, it was pretty fantastic. I was actually shocked that it could produce anything given the environment it was working in, which was abusive, erratic. Right? Because Twitch would just be all of a sudden like, Devin, you need to add collectibles now. And then it's like, okay. Right. And then it's like, Devin, why have you not fixed this bug? And then Devin's like, okay. Yes. And so it's just like constantly going back and forth. There we go. It looks like we got some cheese spreading. So I'm just to triple make sure. All right. So we did get it. All right. Oh, there we go. This could be it because that edited the file that it should have edited. All right.
Come on, Devin.
Here we go. Oh, wait. If I'm not mistaken, there's also the game.js. There's still the spawn cheese state is still broken a little bit. So I'll just go 3.5, 4.0. Yeah, right.
Help Devin out a little bit.
Yeah, I think it's just a little bit broken. 4 to 3.5. There we go. Give it a couple cheeses.
Yeah, Yeah, I know how it is.
Oh, man, it keeps breaking right there. There's radius is negative. We have a negative radius right here when drawing a projectile.
Oh.
Yeah, that's too bad.
Well, still no cheese from Devin.
Yeah, no cheese from Devin. And obviously super negative radiuses. So nobody knows what happened there. But we tried. Devin did a pretty good job of getting somewhere.
Yeah, like I said, and like you were saying, just that being able to understand what was being asked for and produce some code, even though it was bad, that sort of did something like that is pretty good, right? And so, like, that's a major achievement in computing. So good on the AI people for getting that far, right? Is this a coding assistant I could ever use? No. But my understanding is that people sometimes use these as glorified search engines, right? Like, hey, I want to create this in React, and it kind of has this very deep knowledge of like random APIs and stuff. Maybe that does help, right? Because you can like look at that code and go, oh, so it's these weird calls or whatever. That seems like a more plausible use case right now.
Oh, I got cheese.
Dude!
Let's go. Okay,
Look at that bob time. Look at that bob time.
That bob time's crazy. Let's move it a little bit further away. Let's get it a little bit out. Oh, look at that cheese. Oh, there's the cheeses.
Dude.
Oh, look at that cheese. Look at that bob. Oh, that bob's coming right at us because it's a Y bob.
Yeah, it's
so
Y
this
bob.
one is back and forth, and this bob's throbbing at us.
Yep, throbbing bobbing.
Man, that is some cheese.
Oh my goodness.
That is some cheese right there. Look at that.
Great work, Devin.
Great work.
I mean,
it
you
forgot to call
had to handhold it, but
it forgot to call what's it called? It forgot to give it coordinates and it forgot to call render.
To render it.
Yeah, but I took care of that. That's easy. That's easy program. That's something that a human could do. That's the obviously easy part. Devin wrote the hard parts, like the actual rendering.
Quote unquote hard part called draw image, but okay.
Hey, it was hard, buddy.
Okay. Sorry, Devin. I'm sorry.
Yeah. Awesome.
All right. Well, I think that was a tremendous success. You got the cheese on the screen. I should say Devin got the cheese on the screen, and all you had to do was browbeat him a little bit and hold his hand a little bit. So
Yeah. And the rest of the game, there was no hold handing. So just a hold handing, hand holding.
Yes.
Just so you know,
like
the rest of it was purely done with automated merges on GitHub and Twitch chat, getting to chat once every approximate 3 minutes.
I'm gonna go ahead and I really deeply apologize to Devin because I especially after his mother's passing and all. But the fact that it doesn't sort the cheeses with the enemies or the walls is a bit of a problem, Devin. It's a bit of a problem.
Mother is, in fact, not proud right now.
I think she may be back rolling over in her AI grave.
In her very shallow, destitute grave due to the poor behavior.
Not great.
All right.
Not great.
Hey, Casey, this was an excellent code review. Where can people find you at?
Oh, they can find me at computerenhance.com if they would like to. Thank you for the shout out, Prime.
I just realized we probably should have done that a bit sooner. But computerenhance.com.
I have provided zero value to this stream. I don't feel like I deserve a shout out at all.
This was great.
So thank you anyway.
What can people expect to find on Computer Enhance?
Computer Enhance is basically, I do stuff with low-level programming there, just teaching people how performance works and sort of explaining how CPUs work and how your sort of high-level code translates into that. It's just for people who want to know more, like that sort of stuff we were talking about with the FP ATAN there stuff. Or like, where does that come from? Why is there a square root in the CPU and not an ATAN? And how was I supposed to know that? Like, that's the sort of stuff we cover. In fact, right now we're implementing Sign ourselves.
Oh, wow!
Just so people can see how it's done on computer. That's literally what we're doing right now, and I'm just kind of showing them how that would work if you go like, wait. If I don't want to use the math library that does Sign, what's happening? Like, what's the CPU doing? Could I write it myself? And just showing them how to do that. So
that's pretty cool. Well, awesome. Well,
yeah,
thank you for being on here. This was super fun. I mean, I had a blast.
Me too. Me too. Thank you very much for inviting me. Yeah, anytime. Let me know if Devin makes any significant strides in the game. Is he still going to be? Is he going to be up for your chat to keep working with, or is that it? Is he done?
What I was thinking about doing is doing another couple rounds and maybe giving them a chance to make an idle RPG. Because you see those mobile games that's an idle RPG where the game is just a monetization engine, and that feels like a great way. Like, that just feels like the best way to leave something up, because then maybe they could shear bits to make the game react better.
Yep.
Yeah. You know what I mean?
love it.
Yeah.
All right. I'm here for it. I'll be watching.
All right. Take care, Casey.
All right. Thanks for having me on. Have a good one, Prime.
Bye.